Hey YouTubers, welcome to the Cyber Overwatch channel. I am Pragmatic1. In this video, I will be doing a walkthrough of the HackTheBox Analytics vulnerable host. I will provide a walkthrough of reconnaissance through post-exploitation. This will include performing port scanning, service enumeration, web app testing, remote code execution, and local privilege escalation. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. Also, for more free content, please regularly check back on www.cybersec.com. Analytics is a vulnerable host created by the Cyber Geek to allow users to practice ethical hacking techniques. The virtual machine is accessible from the HackTheBox virtual training lab. I went ahead and started my target host Analytics. As shown on the screen, it now has an IP. The first thing I will need to do is information gathering, including port scans and service enumeration. For active information gathering, I'm using nmap on the target host. I'll run the following command shown in the CLI. In general, since I am trying to figure out what ports are open, I'll first want to scan all 65,535 ports using the -p- switch to look for services listing on non-standard ports. When I look at the nmap scan results, I can see that nmap detected 2 open ports, port 22 SSH and port 80 HTTP. As I analyze the results of the nmap scan, going off previous experience, it is likely that Analytics is a Linux host. This is also based on nmap detecting the OS as generic Linux distribution and the SSH service running. The service banners also show Ubuntu as the flavor of Linux. Let's take a look at the first service, port 80. Reviewing the nmap output, I can see that the web server is nginx 1.18.0. In the output, it also shows that the web address is http://analytical.htb. Browsing to the http://analytical.htb as shown in the output brings me to the server not found error message. To resolve this issue, I ran the following command shown in the CLI to add the IP/hostname to my Kali's host file. This command must be run as root. After adding the IP and hostname to my Kali's host file, I was able to load the website when I browsed to the IP. Reviewing the page source, I found some interesting information. There was not information in terms of versions, web app names, etc., but the URL in the login button points to http://data.analytical.htb. Along with manual testing, I will also crawl the web server. Looking at Wappalyzer, it shows some web technologies used by the web app and their versions. Since I am still in the information gathering phase, this information will be good to hold on to. Reviewing this, I can already validate some information that nmap found, such as the OS and web server platform and version. Coming back to the URL found in the page source, as noted earlier, it appears to be linked to the login button on the main page. It is always good to inspect any login web links. When I clicked the login link, I received an error message that the server was not found. Reviewing the error, it is similar to the main website where I had to add the IP hostname to the Kali's host file. I ran the following echo command shown in the CLI to add data.analytical.htb to the host file. After adding the IP hostname to Kali's host file, I tried to navigate to data.analytical.htb, and sure enough, the page loads and brings me to the Metabase login page. Metabase is an open source business intelligence and data visualization tool designed to provide a simple and user-friendly way for organizations to explore and analyze their data. Use cases include business reporting, generating regular business reports and automate their distribution, data exploration, allow business users to explore data without needing technical skills, dashboarding, monitoring key metrics in real time with custom dashboards, ad hoc analysis, perform ad hoc data analysis for quick insights and decision making. Reviewing the page source of the Metabase login page, there's a lot of information to sift through. I was able to get the version of Metabase currently deployed. It's version 0.46.6. Even though I got the version, it's a good idea to see if there are any hidden files or directories. Using fuff, I'll run the following command shown in the CLI to crawl the web server. The -r will follow redirects, -fc will exclude the 401 error responses, and the -t will set threads to 100. Fuff completed the crawl, and based on the fuzzing results for pages and directories of analytical.htb, Fuff found the images, CSS, JS, and data directories and pages, which after manual browsing, I verified that all 3 of the data pages detected by Fuff redirected me to the Metabase login page. Based on active recon, Metabase appears to be an attack vector. I need to investigate if there are any exploits that are currently available. There are a few methods for finding exploits. One easy way is to Google the application name and version along with the word exploit. In this case, I googled Metabase.46.6 exploit, and I was provided with a variety of sources including a CVE number. One of the sources in the Google result was a write-up by assetnote.io. Before attempting to exploit a vulnerability in Metabase version 0.46.6, I wanted to educate myself more on the exploitation of the vulnerability. Based on my review of the available information, version 0.46.6 does not remove the setup token that is first generated when deploying Metabase. This token can be used for authentication bypass. During initial setup, Metabase uses the setup token to complete the configuration. The setup token remains accessible to unauthenticated users by viewing the HTML page source of the login page, where it is embedded in the JSON object, or accessing the endpoint/API/session/properties, which is available without authentication. By providing a crafted JDBC URI, you can exploit a SQL injection vulnerability within the H2 database driver. The crafted URI includes parameters that allow arbitrary code execution. Abusing the H2 database driver allows for SQL injection, which would allow for a reverse shell payload. With gaining an understanding of the vulnerability and how to exploit it, I want to look at my options. I decided to use a POC exploit from Pyrosec. This POC looks pretty simple. I just need to execute the exploit along with making sure I run a listener. I want to clone this repo, so I'll just click on the code button, then click the copy button, which copies the URL. I'll run the following command shown in the CLI to clone the repo. It looks like the repo downloaded successfully. Before I execute the exploit, I want to run a listener. I ran the following command shown in the CLI to run my netcat listener. I'll run the following exploit command shown in the CLI to execute the exploit. Python 3 specifies the interpreter that will be used to run the script. Exploit.py is the name of the Python script being executed. The -u flag is used to specify the URL of the target server. In this case, the URL is http://data.analytical.htb. -t flag specifies the setup token to be used. In this case, it's the token obtained from the Metabase login page source. -c flag tells the command interpreter to use the bash command to execute a reverse shell. This is where the payload gets executed. After executing the exploit, I get the following response. Looking at my netcat listener, there is a visible output that shows that the target host created a session. Now that I got a foothold on the target host, I need to gain some situational awareness. I run the following command shown in the CLI to first understand what account I'm logged in as, second, where am I currently located on the target host directory structure, and third, what are the contents of that directory. Now that I got my bearings, I need to find a method to escalate my privileges. One of the quickest ways to enumerate for escalation paths is running P's and G. As a caveat, it's not always the best idea to rely on just one tool, such as P's and G, but it's fast and allows you to save time during an engagement. Be sure to try multiple methods, both automated and manual, when testing. There are plenty of free resources out there. Google is your best friend and can help you find resources quickly. I recommend bookmarking any resources you've discovered and find useful. In order to upload linps to the target host, I'll need to start my HTTP server using the following command shown in the CLI. With my HTTP server running, I'll upload linps to the /temp folder since it's world writable. I ran the following command shown in the CLI to change directory to the /temp folder. For this walkthrough, I already have linps in my downloads folder. I'll run the following wget command as shown in the CLI to download linps. Based on the wget output, it looks like I successfully uploaded linps. With the linps uploaded, I ran ls-la to number 1, verify that the file uploaded successfully, and number 2, check whether the file has the necessary permissions in order to execute. Reviewing the output, I can see that linps has read-write for the Metabase account, but I need to execute privileges to run linps. To resolve this issue, I ran the following chmod command and ls-la as shown in the CLI to verify that linps is executable. As can be seen in the output, the execute bit is applied. I'll run the following linps command shown in the CLI to find possible escalation paths. The -a flag performs all checks and the -e flag performs extra enumeration. The -a and -e flags combined will trigger extra checks that are more detailed and comprehensive compared to the standard scan. The checks include hidden files and folder searches, extended environment variable analysis, detailed network interface, ERP and routing table information, kernel, scheduled jobs, and package management checks, and not to forget the system and audit logs, security policies, file system, and storage checks. The checks provide extensive information to review, but oftentimes it is what's necessary to find those hidden attack vectors. It's important to keep focused when reviewing pages of output. linps will usually highlight items it finds interesting, but it does not always highlight or find, for that matter, everything. The first thing that I noticed in the linps output was the environment section. information. Looking close, I could see the Metabase username and password as shown in the output. If I skimmed through this output looking for highlighted items, I would have missed it. I didn't find any other interesting items in the linps output. Coming back to the credentials I discovered, I'm not sure what access they grant, but it's always good to start simple and work your way to more complicated possibilities. I'll run the following command shown in the CLI to see if I can log into the target host via SSH. I get prompted to type yes or no, which is a good sign. I get prompted to enter a password. I entered the password I discovered in the environment variables, and it looks like it allowed me to log in. I ran the pwd ls-la and id commands to first see what directory I'm in, second to view the contents of the current folder, and third to see what user context I'm in. The output also shows the user.txt file, which should provide the first flag. I ran the cat command as shown in the CLI to view the contents of the user.txt file. I ran the sudo-l command as shown in the CLI, but the Metalytic account does not have sudo privileges. Using the same method I used earlier, I ran the wget command to download linps from my Kali system. I then ran the chmod and ls-la commands as shown in the CLI to apply the execute bit to linps and verify the change was successful. Based on the output, linps downloaded successfully and I was able to make linps executable. I ran the same linps command I ran earlier. Reviewing the output, nothing really stuck out to me. I decided to take a look at possible exploits affecting the kernel. Grabbing the kernel version from the linps output shown in the CLI, I'll Google for possible exploits. I Googled for an exploit affecting the current kernel on the target host. The search provided several possible results. As I did with the Metabase vulnerability, I wanted to get a better understanding of the game overlay vulnerability. Doing my research, I came across a CrowdStrike write-up that does a very good job explaining this vulnerability. In short, the vulnerability, if exploited, allows unprivileged users to set privileged extended attributes on the files mounted with overlay FS on certain Ubuntu kernels. This bypasses security checks and allows for local privilege escalation. Reviewing the game overlay GitHub page provides a brief description of the CVEs, vulnerable kernels, and exploit usage. With a better understanding of the vulnerability, let me now get a better understanding of this exploit script. The shebang specifies that the script should be interpreted by bin bash. In the comments section, it provides information about the script, including the vulnerabilities it targets, CVE 2023-2640 and CVE 2023-32629. The author, G1VI, and the date of creation, October 2023. The echo statement prints, "You should be root now." To inform the root privileges should be set after running the script, and type exit to finish and leave the house cleaned tells you to type exit in order to exit the root shell and clean up artifacts. In the actual exploit, there's a lot going on and I don't want to get into the weeds. In short though, the main command unshare-rm /sh-c starts a new isolated namespace with a shell. The commands within the new namespace sets up the overlay file system, overlay FS, by creating files and directories using mkdir or make directory. Then it copies specific files from the root file system to the newly created directory. Then it sets up the cap_setuid plus EIP capability to Python 3, allowing it to run with elevated privileges. It then uses mount-t overlay to mount overlay FS. Finally, executes Python 3 with user use privileges. The Python code then sets the effective user ID to root. OS system will copy bin bash to var temp bash and also sets the set UID bit to 4755 on var temp bash to allow it to run with root privileges. Then executes var temp bash -p to launch a privileged shell. rm-rf performs a cleanup by removing the directories and var temp bash. Now that I've gone through the exploit code, I'll just grab the URL in order to clone the repository. I ran the following git command shown in the CLI to download the game overlay exploit repository. Based on the output, I downloaded the exploit successfully. After I downloaded the repo, I changed directories to that folder and copied the exploit.sh file to the downloads folder, renaming it gameoverlay.sh as shown in the CLI. I moved over to the target host shell so I can upload the exploit to the target host using the following command shown in the CLI. Based on the output, I can see that the exploit uploaded successfully. In more cases than not, the uploaded file will not have the execute bit set. To remedy that, I ran the following chmod command shown in the CLI. I also chained it with the ls-la command to verify that the exploit is now executable. With the exploit uploaded, I'll run the following command shown in the CLI and hopefully escalate my privileges. After running the exploit, I get a message stating that I should now have root. I ran the id command to verify and it confirmed that I now have root privileges. Now that I have root, I ran the cd/root command to change directories to the root home directory and ran the ls-la command to view the contents. As can be seen by the output, I can see the root.txt file. I ran the cat command on the root.txt file to view the contents. Now that I have the root flag, I have completed the host. In conclusion, by combining reconnaissance, web app exploitation, and kernel vulnerability exploitation, I was able to navigate the attack chain from initial access to root privileges. I was able to leverage remote code execution to gain a foothold on the target system, discover credentials in cleartext, and capitalize on a kernel vulnerability to escalate my privileges in order to gain the root flag. Thank you for tuning in to this demonstration of HackTheBox's Analytics Vulnerable Host. Thank you for also checking out the Cyber Overwatch channel. If you find this content informative and you are interested in cybersecurity, please like and subscribe to the Cyber Overwatch channel. For more free content, check out the www.cybersec.com website found in the description. If you have any questions, please feel free to leave a question in the comments, or you can send me a message from the CyberSec website listed in the description. Until next time, keep learning. The only way to improve is to keep learning. Pragmatic One, signing off.